All right, so we are doing 1.3, introducing irrational numbers. And just to review, rational numbers we know are what?
Rational.
They are rational, they make sense, but how can we prove that they are rational?
Yes.
How can we prove that they are rational? Martin.
That there is not a number?
Well, the denominator can't be 0. Jess? Help me.
Rachel.
Rachel.
That it can be divided by each other?
Okay. This is a number, right? And this is a number, and this is not 0. So it's the ratio of those two numbers. That is a rational number. Yes. Annalise.
Okay. We can find the number's exact spot on the number line.
Very good. If you can find exactly where it lives on a number line, you know it's a rational number. We're going to use that idea to talk about irrational numbers now. If you're in, and how many of you like language? Like that's your favorite class?
I do.
Okay, so words, and just like in language, in math, they mean something. The prefix ir, I-R, generally means what? Not. So if rational numbers have a specific spot on the number line, irrational numbers, Jess?
They don't have a
They
spot?
don't have a specific spot on the number line. One of the reasons that we'll see is repeating decimals. You can't pinpoint where it is, because the closer you get to it, the more accurate you can get. And then you get more accurate, and then it's even more decimal points. And then you try to get that one, and there's even more decimal points. And then you try, so you start out here, and you're getting closer and closer and closer and closer and closer to finding its home, but you never get close enough because there's always more decimals. Okay? So that idea kind of doesn't make sense to us. It's irrational. It's a number, but it doesn't live on a number line in a specific spot. Okay? So just kind of keep that as your focus about what irrational numbers are.
It's not on a number line or
It's not on a specific set. Like it's somewhere in there, but you can't pinpoint it because the decimal doesn't end, so you can't get precise enough in order to say this is exactly where it lives. So it doesn't follow that rule. You can't find the exact spot, so therefore it's irrational. Okay? One example of an irrational number, you can start with a heading of irrational numbers, and then we'll just kind of write down what we just said.
The date.
Okay?
We're writing this down.
Yes, please. So they are numbers that don't fit that integer on top of an integer form. We called it the m over n in the book. Remember talking about those? Those two letters represent any number where n cannot be 0. And they don't have that exact home on the number line. For example, 1.3 repeating. Since that 3 goes on forever, you can't pinpoint exactly where that is, so therefore we call that an irrational number. The Greek letter pi, representing the relationship of the circumference of a circle divided by its diameter. That is also an irrational number. The decimal points never repeat, and they don't even end. Okay, so pi goes on forever, the decimal portion of it. So 3.141592, maybe, I don't know many of them. So that is also irrational. And there's also this Greek letter called pi, called phi, which is irrational too. Does anybody know anything about phi? Okay, it's called the, do you know?
I've heard of it.
Okay, it's a golden ratio. Some people call it the golden ratio. It's about the relationship of the sides of figures. So, for like a rectangle, if the shorter side is like 1.62 times, no, the longer side is 1.62 times the shorter side, that's the golden ratio. And that's just pleasing to our eyes. So a lot of artwork is done in a canvas size that fits that ratio. Okay? So those are 3 examples of irrational numbers. Why are they irrational? Rachel.
Is it all place on the number line?
They don't have a specific place. You can't find it. It's more and more that you try to get close to it, you just can't get there. Okay? All right. Here's another one just before we go, and then we'll actually solve it. The square root of 2. Think back to our discussion about square root. Remember we did like the easy one, square root of 4 is what? Square root of 4 is 2. The square root of 9 is? Square root of 9 is? 3. The square root of 16 is? In the back, Joe.
8.
Good try, but that's divided by 2. You got to try to remember you're looking for a number times itself that equals 16. Logan.
4.
Good. The square root of 25, everybody.
5.
36. Good. Square root of 49.
7.
Square root of 100.
10.
Good. I tried to trick you. All right. So square roots of some numbers are irrational. Okay. This one happens to be irrational. What we call perfect squares, like 2 squared is 4, so 4 is called a perfect square. That's a rational number. Square root of 4 is rational because it's a perfect square. Okay? Now, we have to do a couple of things with square roots. First, we have to figure out where that lives between what two numbers. Because we'll never know exactly where it lives, all we can do is approximate it. Okay? Break it down and see if we can get it about where it lives. Okay? So if this is my number line, between what 2 numbers do we think that might live? Think about it for a second. Give everybody a chance to think. If I'm looking for one number that when I multiply it by itself, my answer is going to be 2. What could that number be, and between what 2 numbers do you think it is? Mike?
Between 0 and 3.
Well, between 0 and 3, yes, but I want one number, like 1 and 2, 2 and 3, or 0 and 1. Just one, like one number there, one number there. You covered 4 numbers, like 0, 1, 2, 3. Okay? So what 2 numbers?
1 and 2.
Between 1 and 2. How many agree with Mr. D, we'll call him? Marty, you agree? How many else agree? It's going to be between 1 and 2. Anybody think it's between 0 and 1? Good, because if you think, if the upper end of, if it were 1, 1 times 1 is 1, so you can't ever get more than 1 if you're squaring 1. So since we're looking for 2, it had to be more than that. And it is between 1 and 2. So 1 squared equals what? 1 squared equals 1. And 2 squared equals
4.
4. Okay? So that's how we kind of know that it's between 1 and 2. Right? All right. So now we take our calculator and we do the square root of 2 on your calculator. Okay, here's your square root sign, and do the square root of 2. Lexi.
So 1.4142.
1.4142. 1.412?
412. Wait,
4.42,
1,
35, 62. Now, because the calculator only has that much display, it stops. But this number does not stop. So instead of dealing with that whole number, we approximate it. And we're going to round it to 2 decimal points. So 1.41. And we'll use our little about symbol. It is approximately equal to 1.41. Now I can go ahead and say, oh, well, if this is 1.5, then 1.4 is about here, and then I'll say, okay, there's the square root of 2 on a number line. Now that part there you don't have to be real careful with, but that's where it lives. Okay? So I'm going to give you a minute to copy that one down, and then we'll try one for practice.